Let's fix this. That should be a C. Okay. The y coordinate right here, they tell us that as x approaches C, here let's see, if f of x can be made arbitrarily close to R by taking x sufficiently close to C. So as x gets closer and closer and closer to C, then if my y gets closer and closer and closer to R. So that R would be my y coordinate there. Now, this particular graph, I have a closed circle right there. You could actually go to that point, right? So we could get, as our x gets closer and closer and closer to C, the y value, so if we're thinking about y values here, y gets closer and closer and closer to R. Now, if I had an open circle there, if I erase this and put an open circle, it's still true, even though I don't actually get to that point. Because when we put an open circle, we mean we're not including that point right there. But limits are not about whether or not that point exists, right? Limits are about if you're getting close to a y value. So as my x value gets closer and closer and closer and closer to C, my y value still gets closer and closer and closer to R. It doesn't get there, but it gets closer and closer. I use the example whenever we're talking about limits. If I am going to go halfway to my cabinet over there, so I would count off the blocks, I'd go about halfway. I'm just going to estimate here. I'd be halfway to my cabinet, right? If I go halfway to my cabinet again, I'd end up about right here, right? If I go halfway to my cabinet again, I'm right here. If I go halfway to my cabinet again, I'm right here. Now, I can't really demonstrate this any further, but theoretically, do I ever get to the cabinet? No. If I was a point with, because whenever we're talking about math, we would boil me down to a point that has no width, which is not like actually the case. But I would never actually get to the cabinet. I would approach the cabinet, right? As my position on the floor approaches the wall, my distance to the cabinet approaches zero. I get closer and closer and closer to the cabinet. But theoretically, I'd never get there, right? Now, I'm a person. I do have width and height and everything. So, I can actually get to the cabinet. But if we're looking at it mathematically where I'm a point, I never get there. So that's kind of what we're talking about here. So, whenever we're looking at notation, because right now we're really only focused on notation, x approaches C. This comes from your x-axis, right? So it's the value you're approaching on that x-axis. This R right here is from your y-axis. Let's write that down. Limit just tells us we're looking for that number that you're approaching. F of x is just your equation. Sometimes we just call it f of x. Sometimes we would actually put the equation there, x squared plus 4x plus 3 there. So let's look at some problems. We're not working them out right now. We're just writing them out, okay? So if I see something like this, I just want us to write it out in words, okay? So what we could say for this one doesn't have an answer to it. It doesn't say that this equals something. This is the limit as x approaches 5 of x squared plus 7. Oh, this really needs period. It's not really a sentence. You also could word this a little differently. I'm just going to write it so we see that, grammatically, you could just do these a little different. It means the same. So you also could say the limit of x squared plus 7 as x approaches 5. right? So you can kind of flip-flop that order that you put it in. It doesn't matter, but that is how you would read either one of these. That's how you would read this. Okay. Does anybody remember from pre-calc, because we did do a little bit of this, what this right here means? From the negative side, which is going to be on our left, right? So whenever we see a plus or minus behind the number that we're approaching, that means left or right. Okay, so for this one, we would say the limit of g of x as x approaches a from the left. If there is not a plus or a minus behind it, so if it has neither one, it would be from both sides. You never have to write that. If you do, it's fine. It's not going to hurt you. Because if there is not a plus or a minus, it is assumed it's from both sides. So if you just write limit of x squared plus 7 as x approaches 5, if you don't put from the right or from the left, we assume that you mean from both sides. So you don't have to write from both sides. If you did, it'd be fine. But if there is not a plus or a minus after it, then assume it's from both sides. It's not the same as like positives and negatives, where if there's nothing there, we assume it's positive. If you mean from the right, you will put a plus behind it. Okay? Do the next couple on your own. Write those down. Okay, Troy, what'd you get on 3? Perfect. That's exactly what I have as well. Everybody good there? All right. Let's see. Abby, what'd you get for 4? Perfect. That's also what I have. All right. So just basic notation. Everybody good here? All right. Let's look at going from words to the limit notation. We are given a function f where f of x equals square root of x minus 3. Find the limit of f of x as x approaches 3 from the right. So we got a couple options because they gave us f of x, but they also told us what it stood for. So you could write it like this, limit, and you could just call it f of x. Or you could do the limit and you could call it square root of x minus 3. Do not call it x equals square root of x minus 3. Don't put the equal sign there. That makes it look like that. And we need x approaches 3, and it's from the right, so we put a plus behind it. So either one of these would be fine. Okay. Same thing is true for number 6. I can call it f of x or I can call it e of x. Let me show you something you cannot do, and you're going to do it. Somebody's going to do it. Several somebodies are probably going to do it. When we start doing limits, students always seem to want to do this. Limit as x approaches 9 from the left. Like that. Just that. You always have to be taking the limit of something. There has to be something that goes right here. I call them naked limits because they don't have a function that they're taking the limit of. I don't think that's a mathematical term, naked limits, but we do not want to see any naked limits anywhere. So make sure that you always have either like an f of x there or an equation of something there. It can't just be limit with nothing behind it. Okay, these are a little trickier because of the wording of it. So for this function, x plus 1 over x minus 3, f of x can be made arbitrarily close to 3 by taking x sufficiently close to 5 but not equal to 5. So this arbitrarily close by taking x sufficiently close, you're talking about x is approaching something, it's becoming sufficiently close, and your f of x or your y is becoming arbitrarily close. So you're talking about approaching, like me approaching the cabinet, right? So that should tell you you're dealing with a limit, because it doesn't say limit anywhere here, right? And I always start with the x first. X sufficiently close to 5. That's x is approaching 5. It doesn't say anything about left or right, so we're just going to assume it's both sides. We're not going to put a plus or minus. Right here, I need an equation. That's going to be where I put my f of x, or I can put the x plus 1 over x minus 3 if I'd rather. Now this one, I have not done anything with that 3 right there. F of x is made arbitrarily close to 3. F of x is on your y-axis, right? The y-axis is where your answers come from. So for this one, you would put equals 3. Because of the wording, sometimes it's a little hard. I just always stick with the x first, and then that other number is probably going to be your answer. So the ones we've done before didn't really have answers to them. We didn't have equals anything, but this one we do. Okay, so as x approaches infinity, the value of the function f of x, which equals 5 over x, approaches 0. So this one also doesn't say limit, but it talks about the value of the function, which is your y value, is going to be approaching 0. So this is the limit as x approaches infinity of, you could do f of x, let's do 5 over x, just so you guys see. It doesn't matter. F of x, 5 over x, either one. It approaches 0. So this one also has an answer. That equals 0. All right, try 9 on your own. Okay, who thinks they've got this one? What do you think, Luke? Good. Perfect. I did this and put a g of t, but I think you'd be okay without the of t part there as well. Very good. I like that, Luke, because did anybody have x approaches 6 right here? Sometimes they'll use different variables on you. The t is like your x in this case, so you would really want to use the t. On the AP exam, if the problem has a t in it, and you use an x instead, but you do everything else right, they usually do not take off for it unless there is also an x somewhere else in that problem. If there is also an x somewhere else in that problem, then they don't know whether you really meant t or x, and you're not going to get credit for your answers. But if the whole problem is in t's and you just accidentally call it x the whole time, they will grade your work, not that variable. All right, so notation, everybody feel good on that? Not too bad. All right, let's look at some graphs. This shouldn't take long. So, we're going to look at limits graphically, and I may have hole punched this on the wrong side, did I? Really backwards, sorry about that. So this is actually what looks like the back. So in order for a limit to exist, the limit from the right and the limit from the left have to be the same. Now, whenever you are answering a limit problem, your answer should always come from the y-axis. Okay? So if we are doing, for this first example, the limit as x approaches a, I'm going to put myself a vertical line right here at a. Right? That is the line that I'm approaching. That's where my x equals a. So from the left, if I'm on my graph and I approach where x equals a, which is approaching that dotted line, I end up right here. It does not matter if it is a closed circle or an open circle. I ended up right here. I'm going to look at the y-coordinate that goes with that point, which is c for this. So always look at the y-axis for that point. So my limit as x approaches a from the left is c. From the right, I would start over here. I would approach that dotted line that is where my x equals a, because x equals a is that vertical line, right? I do have an open circle here, but it doesn't matter because limits are what you're approaching, not whether you ever actually get there or not. So I don't actually get to this point, but I approach this point, right? I'm getting really, really close to the cabinet. Just theoretically, I'm never there at the cabinet. So I'm going to look at the y-coordinate for that point, and I'm going to get b. But if I'm asked for the limit as x approaches a of f of x, from the right side I go to c, and from the left side I go to b. From both sides, I can't give an answer for that, right? Because it's not the same. So for this, we would say does not exist. And in my AP Calculus Facebook group, which is actually marvelous, like all the famous people that do the videos and stuff for AP Classroom, like Mark Corrali does a lot of them, and he's on he will answer. You can put in a question on Facebook, and he will answer your question personally. So it is actually really wonderful. He said he does not like to see that equal sign right there because you can't equal something that does not exist. So if you have to say that the limit does not exist, it's better to write that sort of as a sentence instead of saying equals does not exist. That, I don't know if it's something they count off for, but to be precise, you wouldn't put the equal sign. I don't mind if you do D and E, but and really even on the exam, they're probably going to take D and E if you write that out because it's a really common abbreviation. But to be safe on the exam, we generally don't want to abbreviate things because there is no list of accepted abbreviations. So from year to year, they could decide to accept or not accept. I don't see D and E ever being not accepted, but it's possible that it might not be. So that does not exist. I didn't put this on here, but let's add it. What is F of A? Let's see. So that when you're seeing F of that value, you're looking for where the closed dot is. And that closed dot is up here, and its y-coordinate is C. Okay, we'll look over at the next one. Limit as x approaches A, so I'm going to put my dotted line here at A again. As I approach from the left, I go to this point. There's an open circle, but it doesn't matter for limits, right? Open circles are fine for limits because you're just approaching. You don't have to get there. You have to approach it. And I get B for that y-coordinate. From the right-hand side, I also approach B. So if my limit from the left and my limit from the right are both B, then my limit from both sides is B, even if it's an open circle. Now that graph is not continuous, and we'll talk about that more later, what it takes to be continuous, but the limit exists at that point. So what has to happen for your limit to exist is your two sides have to meet at a point. It could be an open circle or a closed circle, but they have to meet at a point. If you go from one side over here and one side up here, then that's not going to exist. Or if you have asymptotes, that won't exist. What is F of A on this one? No. But there's another word. It's kind of does not exist. We wouldn't call it no solution either. But, I mean, you're thinking the right thing. You've just not got the right word for it. It started with a U. Undefined. And again, they don't really like to see equals undefined because you can't equal something that's undefined. So, F of something, you're going to use undefined. A limit, you need to say does not exist. It's a real fine point of language that I get that if you put D and E for that, you probably knew what was happening. But technically, if we're asking for a value of a function, it's undefined, and then it's going to be does not exist for limits. All right, the actual value of a function at a given point does not have to match the limit. So if I look at the limit as x approaches P, which P is right here. I'll look at limit as x approaches P. For this, Troy, what is my limit as x approaches P? It's R. Okay, even though there's an open circle, it's R. However, Miles, what is F of P? Q. Okay, because right here, there's my y-coordinate. Those two don't match. It's going to mean it's not continuous, but the limit can still exist. And we'll talk about continuity later, so you don't have to worry about that too much right now. All right. I'm going to go through these fairly fast. I need F of A. F of A is right here. I'm looking for closed circle. It's right here. Y-coordinate of that, because it's on the x-axis, is 0. F of B. I'm looking right here, and if you see this, B's right here. If you see it looking like an asymptote, assume it is an asymptote here. I'm intending that to be an asymptote. My hand-drawn graphs aren't beautiful. But that looks like an asymptote. Do you ever actually touch an asymptote? No. So that would be, oh, what word? No, undefined. And really, I shouldn't put that equal there, but. Then I've got f of 0. X coordinate is 0 right here. It's right up here. Y coordinate is G. Okay, but 4 is going to ask me for the limit as x approaches 0. So if I go from both sides of this, for that limit as x approaches 0, I go to this open circle right here. It's fine that it's open circle because limits approach, not actually get there, right? So the y coordinate of that is f. Kayla, what about number 5? Limit as x approaches a from the right. Yes, I was looking at my other right. You're right. It is f. For 6, Smith, what about the limit as x approaches a from both sides? Does not exist. Okay, because we don't meet from both sides. Lucian, what about the limit as x approaches b? It can be two things. It can be does not exist. Okay, or you have a vertical asymptote there, and both sides are going up, right? So what is up there? Infinity. Now, technically, limits at infinity do not, or limits that equal infinity do not exist. Because if you go down the road and you see a speed limit sign that says speed limit infinity, there's not really a speed limit, right? You can go as fast as you want. So you may see either one of these. You could put either one and it would be correct. You wouldn't see, like if this is multiple choice, they would not put both of those answer choices there. Okay, let's see. Troy, what about 8? Limit as x approaches c. 0. Perfect. And sometimes that throws kids off because there's not a dot there, but if it's a solid line, it's just a solid dot at that point. And then, let's see, Reagan, what about the limit as x approaches d from the left? D, yes. If it said from both sides, it would be does not exist, or if it was from the right, it would not exist. All right, so we got an assignment for this. The key for this is on Canvas. I will most of the time put the key up for you guys so that you can check what you've got. So this will be due on Monday. Day, a great weekend. So much better starting on a short week than having to start on Monday. Yeah. Whenever you start on Monday, you can barely make it. Right?